I'm John Woodward. I'm the Dean of the School of Education at the University of Puget Sound, and I was chair of the Math Problem Solving Guide for grades 4 through 8. Grades 4 through 8 are critical periods for kids learning mathematics. We even see that by looking at the international data. And one of the things that's indicative of mathematics instruction in other countries in the world, particularly countries like Japan that have always done well on math assessments, is that a significant portion of their classroom instruction across a week's period of time, for example, involves problem solving. Math problem solving has traditionally been thought of as just word problem solving, and that's true. We can look at an example where students are asked to configure a pen for horses using the same parameter in a different area. But we can also think about math problem solving as symbol manipulation. For example, students can look at different solutions to algebraic equations and talk about the different strategies used to solve those equations. Another example is where students are simply given a simple visual setup, how many squares on a checkerboard, and asked to answer that problem using some kind of visual analysis. The checkerboard problem is a really good problem in part because people think the answer is obvious. Anybody who's played checkers or chess, look at the board and say, well, okay, let me remember, yeah, that's right, there are 8 by 8 or 64 squares. But it's obviously more complicated than that when you start to analyze it visually. You've got the larger square that frames the checkerboard, and then as you think about it further, you see patterns. You see 2 by 2s, 3 by 3s, 4 by 4s. There are all kinds of square patterns inside that checkerboard. The panel derived over time 5 major recommendations that are supported by empirical evidence. But for the first one, where there isn't a lot of research, all of them have moderate or strong levels of evidence that support their practices. One of the first recommendations that's quite important is that teachers plan for problem solving as part of whole class instruction. The idea is problem solving is not to be left to homework or independent seat work. That creates its own problem because we can't specify how many minutes per day or how many hours per week. We simply feel that mathematical problem solving should be a more central portion of the instruction throughout, say, a unit of instruction. So the recommendations begin with planning very clearly for problem solving, making sure that the problems are appropriate to the content that kids are learning, that they vary in their difficulty level, that they're sensitive to kids' background knowledge, their language use, those aspects before they even begin the problem solving. A second recommendation has to do with helping kids monitor their strategies as they solve the problem. This may begin with a task list of some kind where kids can think about strategies that they might use in solving the problems. We also recommend that teachers in the initial phases of problem solving talk out loud or model how they go about working through a complex problem. A third recommendation has to do with the visualizations of problems, using appropriate representations. These can be number strips, these can be diagrams, a variety of things come into play that help kids break down a problem and visualize it as they work their way toward a solution. A fourth recommendation has to do, and this is really quite critical, that kids spend time seeing and listening to a variety of strategies for solving a problem. That's where that aha, I've never thought about this before comes from. It makes sense that students are immersed in their own way of thinking about a problem and solving it and come to think that that's the only way to solve it. What becomes critical is for kids afterwards to hear different solution strategies. The importance of this is this builds greater cognitive flexibility and different ways of looking at how they can solve problems. And the final recommendation has to do with connecting the problem solving with the mathematical notation. A lot of times people think, well, they've solved the problem, they've gone through the process, kids have talked about strategies, but then they forget to connect it to the formal mathematics that kids may be studying at that point in time. I can think of a number of key issues that teachers need to consider when they think about problem solving. The first and foremost one is the amount of time they're going to allocate to the problem solving. That needs to shift. That's not to say again that there's going to be 15 minutes or 20 minutes per day, but it needs to have a greater presence across the week, across the unit of instruction. The second one, which also involves planning, has to do with ensuring that you're meeting and attending to the linguistic background, the cultural background of the students you're working with. The third thing that I would think that would be very important for teachers to consider is just the types of problems. Ask themselves, What's the purpose of the problems that they want to use? For example, should they provide several problems on a new topical area, or is the purpose of problem solving to develop that persistence, to get them to be able to work with a problem that's novel and has an unusual set of characteristics, irrelevant information that they have to struggle with? Students need to persist in their problem solving. You see this very clearly by the time they get to high school. So the ability to stick with a problem, deal with aspects of a problem that are unknown or unclear at first, is a central part of mathematical problem solving and success in mathematics.